trigonometric equations with multiple and half-angle identities. Today we're going to be looking at trigonometric equations that contain parts of the equation where we may have a double angle in it. And if so, we may have to replace that part of the equation using one of our double angle identities. As a reminder, these are the double angle identities. Remember, we have 3 double angle identities for cosine, 1 for sine, and 1 for tangent. Solve each equation for the exact solutions over the interval between 0 and 360. So we're trying to solve this equation for one of the variables. So the first thing that I would do is I would get rid of, if you'll notice, both of these sides of the equation. The trig function has a 2 in front. So to get rid of that, I would divide both sides by 2. And we're left with sine of theta is equal to cosine of 2 theta. Well, that 2 is not being multiplied times the trig function like the other 2 was. It's inside the trig function, so this is a double angle. So in order to undo that, or to be able to deal with that side of the function, we're going to replace it using a double angle identity. Now, our double angle identities for cosine, if we go back and look at them, our double angles for cosine, the first one has a cosine squared and a sine squared, and then we have 2 cosine squared of a minus 1, and then we have 1 minus 2 sine squared of a. Well, if I want to be able to solve this equation, I would change this cosine to match this other side of the equation. So I'm going to use that double angle identity that has the sine in it. All right, so I'm going to replace sine of 2 theta with 1 minus 2 sine squared theta. Okay, and now I want to move everything over to the same side of the equation because now, as you see, we have a quadratic equation. And remember, if we have a quadratic equation, we're going to either factor or do the square root method. This has 3 terms, so we're going to move everything over to one side so that we can factor. So I'm going to subtract 1 from both sides. Do it this way. Subtract 1 from both sides and add 2 sine squared theta to both sides. Okay, so that gives me 2 sine squared theta plus sine of theta minus 1 equals 0. All right, and now I can factor that. Since this is a trinomial, this would factor into 2 binomials. I would have 2 sine theta and sine of theta. The only factors of 1 are 1 and 1. Since my second sign in my trinomial is a minus, I know that the signs in my 2 binomials are going to be different. And to get a plus sine of theta in the middle, my bigger product is going to have to be plus, and my other one's going to be minus. Okay, so that is my factored equation. So now I need to take each factor and set it equal to 0 and solve. All right, so I have 2 sine of theta minus 1 equals 0, and sine of theta plus 1 equals 0. All right, so that gives me 2 sine of theta equals a positive 1, divide by 2, and I get sine of theta equals 1/2. Remember, when we're trying to solve for the variable, to get that trig function off of the angle, we take the sine or the angle inverse. So we're going to take the sine inverse of both sides. If I take the sine inverse of both sides of the equation, that gives me theta is equal to sine inverse of 1/2. Okay, because the sine and sine inverse cancel each other out, so when if I took the sine inverse of this side, they would cancel, and then that gives me the sine inverse of 1/2. Okay, so and then I'm going to do, for my other factor, I'm going to subtract 1 from both sides, so I get sine of theta is equal to -1, and then I take the sine inverse of both sides again, and that gives me theta is equal to sine inverse of -1. Okay, so I need the places, the exact solutions for these values, or for these angles between 0 and 360 degrees. Well, sine is 1/2 at 30 degrees and at 50 degrees. 150 degrees. 30 degrees and 150 degrees. And its sine is -1 at 180 degrees. So those are my solutions for this equation: 30 degrees, 150 degrees, and 180 degrees. Here we have cosine of 2 theta plus cosine of theta equals 0. So again, with that cosine of 2 theta, I am going to use a double angle identity. But I'm not going to use the same double angle identity I used just a minute ago. The one I used before, my other angle in the equation was sine, so I used this double angle identity. Well, this time my other angle is cosine, so I'm going to use this double angle identity, 2 cosine squared of A minus 1. So I'm going to replace cosine of 2 theta with 2 cosine squared theta minus 1 plus cosine of theta equals 0. Okay, so again we have a trinomial. We have a trig function that's squared. We have a linear term, and then we have a constant. So I'm just going to rearrange this and get it in descending order so that we can factor it. Okay, now that we have the trinomial in descending order, I'm going to factor it into 2 binomials. Two cosine squared of theta. When I think about what I need to multiply to get those, I would multiply 2 cosine of theta and cosine of theta. Again, the only factors of 1 are 1 and 1. My signs are going to be different, and my biggest product needs to be plus. So plus and minus. Okay, so then I'm going to take each one of those, set them equal to 0, and solve. Alright, so 2 cosine of theta minus 1. I'm going to add 1 to both sides, and then divide by 2. And this gives me cosine of theta equals 1/2. Take the cosine inverse of both sides, and I get theta is equal to cosine inverse of 1/2. And then for my other factor, I'm going to subtract 1. And that gives me cosine of theta is equal to -1. Take the inverse of both sides, and that gives me theta is equal to cosine inverse of -1. Alright, so the angles whose cosine is 1/2 would be 60 degrees and 300 degrees. And then cosine is -1 at 180 degrees. So those are the solutions to this equation. All right, here we have sine of 2 theta is equal to cosine of theta. Okay, so this time we have sine of 2 theta, a double angle for sine. So if we look at our double angle identities for sine, we only have one choice. The double angle identity for sine is 2 sine of theta times cosine of theta. So that's what I'm going to have to use. And I'm going to replace sine of 2 theta with 2 sine of theta cosine of theta is equal to cosine of theta. Okay, so I'm going to, again, this has more than one trig function in it, so it's not just linear, so I can't just try to isolate the variable. So let me move everything over to one side and see if I can factor. All right, so if I do that, I'm going to subtract cosine of theta from both sides of the equation. Well, of course, these are not like terms, so I can't subtract them. So I have 2 sine of theta cosine of theta minus cosine of theta. Well, remember when we were solving equations in the other lesson, if we had more than one trig function, we would either need to replace it using an identity or see if we could factor it out, factor one of the trig functions out. Well, we have 2 terms here, and both of those terms have a cosine of theta in it. So let's just factor out cosine of theta. All right, so if I factor out a cosine of theta, I'm left with 2 sine of theta minus 1. All right, so now my equation is factored. And I'm going to set each factor equal to 0. Cosine of theta equals 0. And 2 sine of theta minus 1 equals 0. For the cosine of theta equals 0, I take the inverse of both sides, and I get theta is equal to cosine inverse of 0. And for the other side, first I'm going to add 1 to both sides. So that gives me 2 sine of theta equals 1. Divide both sides by 2. And I get sine of theta equals 1/2. And again, I take the inverse of both sides. So I have theta is equal to sine inverse of 1/2. Well, cosine is 0 at 90 degrees and at 270 degrees. And sine is 1/2 at 30 degrees and 150 degrees. So all of my solutions are 30 degrees, 90 degrees, 150 degrees, and 270 degrees. Now we're looking at some equations that we need to solve for exact solutions over the interval between 0 and 2 pi. Well, this has cosine of 2x is equal to the square root of 3 over 2. Well, this is a linear equation, and we can isolate the variable in this equation. Okay, so we can isolate the variable. We can isolate 2x by taking the inverse of both sides. So if I take the inverse, cosine inverse of both sides of the equation, the cosine inverse and cosine cancel, and I'm left with 2x is equal to cosine inverse of square root of 3 over 2. So we're down to looking for the values or the angles where cosine is square root of 3 over 2. So the places where cosine is square root of 3 over 2 are at pi over 6, 11 pi over 6, 13 pi over 6, and 23 pi over 6. But that's not where x equals those values. That's where 2x equals those angles. So I have to solve for x. So in order to solve for x, I would just divide everything by 2. Divide both sides by 2. Well, when we're dealing with those fractions, when I divide by 2, it's the same thing as multiplying by 1/2. So if I multiply each one of those fractions by 1/2, this is going to give me pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. And those are my solutions for x. Here I have the sine of 3x is equal to -1. Okay, so I'm going to do the same thing that I did in the previous equation. I'm trying to get to the x. Well, I have to work my way into it. So the first thing I have to do is get rid of that sine, and I do it by taking the sine inverse of both sides. So if I take the sine inverse of sine, sine goes away, and I'm left with 3x is equal to sine inverse of -1. Okay, well, sine is -1 in one place on the unit circle between 0 and 2 pi. Sine is -1 at 3 pi over 2. Well, I forgot to mention something in the problem before this. Even though our directions say that it's between 0 and 2 pi, because of the fact that this is this would be a triple angle, we have to increase our interval. So we need to, instead of our interval being between 0 and 2 pi, our angle is 3x, so we need to multiply or increase our interval times 3. So the interval for this equation is actually going to be between 0 and 6 pi. Now, we did that in the previous equation. If you'll notice, the values or the angles that I listed went up to 23 pi over 6. Well, that was because we increased our interval times 2 because we had cosine of 2x. So we increased our interval to between 0 and 4 pi. So that 24 pi over 6 would actually be 4 pi. So that's why we listed so many values. I forgot to mention that. So that's what we're doing here. We're looking between 0 and pi over 6. So not only do we have 3 pi over 2, but we also have 7 pi over 2 and 11 pi over 2. So when we're looking for 3x, that's for 3x, that's going to be in the interval between 0 and pi over 6 because it's 3 times the angle. Okay, but now we need to solve for x, and to do that, we're going to divide everything by 3, divide both sides of the equation by 3. Again, when I divide a fraction, if I'm dividing the fraction by 3, I'm actually multiplying by 1/3. So this would give me x is equal to 3 pi over 6, which of course would reduce to pi over 2. 7 pi over 6, and 11 pi over 6. All right, let's look at this equation. If you'll notice, we have a sine of x over 2 on both sides. So we have the same trig value on both sides. So let's combine those. I'm going to add sine of x over 2 to both sides of the equation. So that gives me 2 sine of x over 2's is equal to the square root of 2. Okay, so now we want to solve for x, so I'm going to divide both sides by 2. So that gives me sine of x over 2 is equal to the square root of 2 over 2. So now we're going to take the sine inverse of both sides, and that gives me x over 2 is equal to sine inverse of square root of 2 over 2. Okay, well, since this is x over 2, this is half of the angle. Instead of a double angle or a triple angle, this is a half angle. So we're going to have to, again, alter our interval. So since our regular interval was between 0 and 2 pi, now we're going to take half of that. We're going to divide those by 2. So our interval where we're looking for this value is going to be between 0 and pi, because that's half of it. We're dividing by 2. So the places where sine is square root of 2 over 2 in the interval from 0 to pi would be at pi over 4 and at 3 pi over 4. All right, and then to solve for x, we would just multiply each term times 2. So that would give me x equals, that'd be 2 pi over 4, which would reduce to pi over 2. And this would be 3 pi over 2. All right, here we have sine of x over 2 is equal to cosine of x over 2. Well, we have two different trig functions. We're not going to be able to factor a trig function out, so if we look at different identities to try to replace one of these to get them to be the same trig function, we could look at a half-angle identity, but if you'll remember, those half-angle identities they all have radicals in them, and so that would be really messy and really difficult. So another identity that I know of that relates sine and cosine is the Pythagorean identity. So if you'll remember, the Pythagorean identity says cosine squared of theta plus, or sine squared of theta plus cosine squared of theta equals 1. And I can rearrange that to change one of those trig functions into the other. All right, but in order to do that, both of these would need to be squared. So let's square both sides of this equation. So if I square both sides of this equation, this is the same as sine squared x over 2 is equal to cosine squared x over 2. Well, I can replace cosine squared of x over 2 with its equivalent based on the Pythagorean identity. The Pythagorean identity says cosine squared x over 2 is the same as 1 minus sine squared x over 2. So now I have the same trig functions on both sides of the equation. All right, so let's try to solve this. Let's get both of the signs on the same side of the equation. So I'm going to add sine squared x over 2 to both sides of the equation. Okay, so that gives me 2 sine squared x over 2's is equal to 1. And then I'm going to divide both sides by 2. So that gives me sine squared x over 2 equals 1/2. Now we need to take the square root of both sides of the equation. And remember, when we take the square root of a number, it's plus or minus. Okay, so we have sine of x over 2 is equal to plus or minus. That would be 1 over the square root of 2, which would rationalize to the square root of 2 over 2. Then we take the inverse of both sides, so we have x over 2 is equal to sine inverse of plus or minus square root of 2 over 2. Okay, again, we need to look at what our interval is. So since this is a half angle, or x is being divided by 2, we have to divide our interval. And our interval, instead of being between 0 and 2 pi, it would be between 0 and pi, because we're dividing by 2. So the places where sine is positive or negative square root of 2 over 2 between 0 and pi would be at pi over 4 and 3 pi over 4. And then we need to multiply both sides by 2 to get x by itself. So if I multiply by 2, which is the same thing, multiply everything by 2. So that would give me x is equal to pi over 2 and 6 pi over 4, which would be 3 pi over 2. Now, there's one thing that we need to note. Anytime we square an angle, anytime we solve an angle by squaring both sides, we introduce extraneous solutions. So we always have to check our solutions if we've squared both sides to see if either one of those is an extraneous solution. Okay, so these are my solutions, pi over 2 and 3 pi over 2. So if we go back to the original equation, sine of x over 2 is equal to cosine of x over 2. Actually, it would be easier if we just backed it up one step. In this part of the answer, where I have what x over 2 is equal to. So if I check my first solution, x over 2 would be the pi over 4. So if I plugged that into the original equation, this is saying sine of pi over 4 is equal to cosine of pi over 4. Well, we know that sine of pi over 4 is square root of 2 over 2, and cosine of pi over 4 is also square root of 2 over 2. So that works. So that first solution works, which means this solution also works. Okay, so then let's look at the 3 pi over 4. If I were to plug those in to the original equation, sine of 3 pi over 4 is equal to cosine of 3 pi over 4. Well, sine of 3 pi over 4 is square root of 2 over 2, but cosine of 3 pi over 4 is negative square root of 2 over 2. So that does not work. This is an extraneous solution. So my only solution is pi over 2.